properties of solids. It's like it that comes in that we will discuss about what intermolecular space is, like what are the modulus of those, what are ratios, what are proportions, what is stress, types of stress, what are laws involved, elasticity, and all other things. So let's start with our intermolecular force or interatomic. Interatomic and molecular force. What is interatomic? What do you mean by interatomic force? Anyone? Interatomic and intermolecular.
So the force between the molecules or atoms?
Force between two molecules or atoms. Okay. Yeah. Any other thing?
Due to the electron cloud of both the atoms.
Okay. Or element of it. Yes. So interatomic means force between two atoms or element. Same way here, force between two molecules. Molecules. What is elasticity?
An object which can be stretched and also be brought back to its original shape and size.
So it won't deform or it will be deformed.
It won't be deformed, sir.
That is elastic in nature. Then what is plasticity?
Which cannot be brought back to its original shape after stretching.
Yeah, in short, this elastic property, it can recover its original shape. Plastic property, it does not recover its original shape. There's a small difference. It regain its original shape. That is called elasticity. So perfectly elastic means after like same way. This is what perfectly elastic means. It's after the removal of some external force, it's regain its position or I mean shape. That is what perfectly elastic. Of force force. So it's regain its original shape. That is perfectly elastic body. Plasticity. It does not. Original shape. So which does not regain its original shape, it is perfectly elastic. Sorry, plastic. Next thing we can say here, stress and strain. What is stress? Can someone tell me? No, we are not talking about human stress or physical stress. We're not going into bio, like I have so much stress and all that. No, no, no. What is stress for? Like some object which is under stress. So what will happen to that object?
So it's like a deformation force acting on a unit area.
Force per unit area, or stress is like a pressure applied.
Yeah, it's a deformation force.
So let's say here, stress is what? Deforming force per area. Or we can say other way also, like stress about that object which is deformed, like we are bending some scale, steel scale, we are applying a force on that area, it will bend. So it takes so much stress to regain its original shape, that is restoring force by area. That also we can say. So stress means deforming force applied on a body, then because of deforming force there is a restoring force also. Okay, so what will be unit for this one? Force by area. What's the unit? Veda? What's the unit of stress? Come on. No?
Newton per meter square.
Newton per meter square. So this unit is similar to
Pressure.
pressure. Yes. So now, is this a scalar quantity or vector quantity?
So isn't it a tensor quantity?
Which quantity?
Tensor.
Tensor. So it does not act as a scalar as well as no vector addition.
Why is
Either.
that?
So wherever like it requires direction, but we are adding it like algebraically. So those are tensor quantity, like current, stress. Those are like tensor quantity. Vector quantity, whenever we are adding forces F1 plus F2 vector, we are not simply adding like this. We are using F1 square plus F2 square plus 2 F1 F2 cos theta. So this is called vector addition. Because it shows magnitude and direction. Here, these are just added as a magnitude only. I mean direction required, but normal vector addition. Not as a, like a vector addition, but not just algebraic addition. Yeah, normal algebraic addition. Tensor quantity. No, types. Longitudinal stress or tensile. Second one, volumetric. What do you mean by longitudinal? Meaning of longitudinal. Anyone? Akshit? What do you mean by longitudinal?
Lengthwise.
Yeah, that is lengthwise. Okay. These are like types of stress, longitudinal and volumetric. Volumetric means volume wise. Now strain. This is the ratio of what? Change in shape or size to the original shape. or size. So strain equals to change in any dimension by original So if it is like that, then what is the unit of it? What can be the unit? Change in length by original length. So what will be the unit? Any guesses? What will be the unit for this? Shirisha? Are you guys there? Shirisha, Veda?
Yes, sir.
Yes, sir.
Okay. Akshit?
Yes, sir.
Mm-hmm. When I'm calling your name, then you should reply. Okay, so what will be the unit for this one? Any guesses for this? Change in size or shape, or let's take length by original length. So what will be unit for that? Shirisha, what will be the unit?
I don't know, sir.
So will it
Okay,
be Newton per meter square?
no. See, think like, what is the unit of length? What will be unit of length? Unit of length.
So it actually won't have any dimension, right? It's basically the ratio we're like taking. So
Exactly.
both will be meter and meter, both of them will
So
get
change in length. If I'm taking size, change in length by original length. So it is no unit. So it is dimensionless. Ratio of shape or size to the original shape or size. But here itself we can understand, yes, it is a shape to the original shape. So in that also we have some types. Strain means ratio of length. Let's say here, change in length by original length. Delta L by L. Next, volume strain. Ratio of change in volume by original volume. Delta V by V. The last one, shearing strain. Angular deformation produced in body. That is, we'll take it as theta delta x by h. How much it got displaced? The original one. How much it got displaced to the original one. Go on, make a note of it. Written? चलो ठीक है फिर. Next is our Mr. Hook. Hooke's law. What it says, like the stress is proportional to strain. Means as much as stress it has, the object has, same strain it will have to regain its original shape. Same strain he has to do to regain its original dimension. That's what Hooke says. More the stress, more the strain. But will it be 100% like that? Because every object has some limit. There is some limitation. If you go beyond that limitation, it will never come back to its original shape. So there is a limit for every object to regain its original shape and size. Those are some elastic limit. So if I take a pen in that, like we can take some, refill of that pen, which is plastic in nature. And same way, outer covering of pen. If I compare those, if I band both, which will tends to break, the outer covering or the plastic inside which is filling the ink? which will tends to break? Outer covering or that plastic inside?
The plastic.
Or plastic inside, right? Because it's like a flexible plastic. This is outer one, it's a rigid plastic. So outer one will break faster and inner one will like a bend. It will also break, but obviously like every object has some limit, as I said. Even nowadays they are claiming some phones which is like a easily like non-breakable, not breakable. Like even I saw some what this advertisement, titanium, yeah, iPhone 15. These are titanium they made. So it will bend, yeah, okay, but it will not break. So likewise, like everything has some drawbacks. So stress is proportional to strain. So if I take ratio of these two, stress by strain is constant. It is denoted by something, let's say E, as per the Hooke's law, Mr. Hooke's law. Which is coefficient of elasticity of elasticity. Or other name is, this constant other name is modulus of elasticity. Just name beyond Mr. Young, Thomas Young. So as I was saying, there is some limit for every object. So let's draw a stress strain curve. Most question from this one. Excuse me. Let's take here point A, point B, point C, and this is point B, E. Let's name these points. This is proportional limit. So in that, stress and strain are in proportion. They increase simultaneously. So there comes some limit B, that is elastic limit. Elastic limit, where like up to which it can handle maximum stress for the that strain. Maximum stress it can handle. Now, when it goes beyond, this enters into the region called plastic region. So this will become breaking strength. And the last point here, rupture or fracture point. Now let's understand this point by point. Now when you see proportional limit, that our whichever we said just now, discuss Hooke's law, it will be proportional. Stress will be proportional to strain, and they will just this increase, that also increase simultaneously. Both increase simultaneously. Then next point is your elastic limit. So in that we can go up to maximum stress which body can recover. So that is the elastic point. Then CD is the plastic region. Okay, where you go beyond this elastic region, enter into plastic region, they will be permanently deformed. So this plastic region has a yield point. Yield point means a point where transition is happening. Elastic to plastic is changing, like so, permanently deformed. Then next comes here breaking strength or breaking point. So what will happen? Name itself we can understand. If we go beyond that, the strain is so much that it cannot sustain and it will break. So whatever stress it happens, that will be breaking or permanent deform. Now that also depends, like metals, if it is metals, they will be like, if it is ductile metal, so it will be like permanently plastic deformation. And if it is like some material, like some plastic, as we discussed before, it will break. That is fracture point. Now, generally, metal has so high fracture point. Remaining anything has low fracture point. It will break. After this breaking strength, it will break. Metal will mend. That is why most of the places we are using metal. At least it will not break, it will just bend. Same goes for our house and all that, whatever. There are so many reasons for using metal in our house, but this is one of the reasons. And if you're like planning to go for some mechanical or civil engineering, these two chapters are the most important chapters. Understanding the properties of solids and how does liquid behave. So these two are the most important properties of solids, that is stress and strain. We need to understand how much stress it can sustain. So okay, you can write those things in your own words. Can someone tell me what is this breaking strength? Let me see were you listening or not. Shirisha, you there?
Yes, sir.
Okay, super. So what is breaking strength? Shirisha, I'm asking you only.
The stress required to break the wire is called a breaking stress.
Okay. Means if we go beyond that point, that strain will be so much high, it will tends to break. Okay. Akshat, are you there?
Yes, sir.
Then what is fracture point?
The load on the wire increases, therefore the thickness of the wire decreases. The wire breaks, and I think that is called fracture point.
So it starts breaking.
Yes.
Okay. Good. ठीक है. I want all these terms right in your own words. Okay. I want you to write in your own words. Like no Googling and nothing like that. You can write in your own words as much as you understood. So tomorrow you tell me what you wrote. If you're done, I can stop
Sir,
this
is
sharing.
elastic limit where it's not stress and strain are not proportional, but then it still can go back to its original shape?
Original shape. Yeah. Up to this limit means.
And
Up
plastic
to
limit
elastic.
is where it cannot go back to its
Yeah.
original shape.
That is done. Now we cannot go back. Like that. So the transition region, there is yield point. I didn't mention here. Okay, but you can mention that. Yield point. Where in the if we go beyond elastic limit, so it is like length is increasing when we are bending it, okay, but no stress there. It is just a point where it has happened. It's going, means in short, it is going under the plastic region. Okay, shall I stop the sharing?